Hello everyone, welcome back to our discussion on College Algebra, and today we will be continuing our review on pre-algebra, and today we will be discussing exponents. So first off, what is an exponent? Well, as we all know, if we have a number like 5 and we square it, the 2 is an exponent. What this means is that we multiply 5 by itself twice. Or we have two 5s in the expression, so this would be 25. So for example, if we had 5 to the 4th, this would again be the exponent, and this means we need to have 4 5s in the expression. So we'd have 5 times 5 times 5 times 5. But what if we have situations where we have multiple variables with exponents? For example, what if we had 5 cubed times 5 7? How do we find this expression? Well, thankfully for us, there's a formula that we can use that's called the product rule to solve expressions of this form. So, the product rule formula states that if A, B, and C are real numbers, then AB times AC equals AB plus C. Now, this might look complicated at first, but really all it is it's saying that when you are multiplying a number with exponents, all you do is add the exponents. So let's take for example, we have 5 cubed times 5 to the 7th. Well, by this formula, we could see that we have A as 5, B as 3, and C as 7. So in order to solve this, we would have 5, 3 plus 7, 5 to the 10th. Again, we can look at another example of 5 to the 24th times 5 to the 6th. Here, again, 5 is A, 24 is B, and 6 is C. So by the formula, we have 5 to the 24th plus 6, 5 to the 30th. Now, you might be asking about variables and how does this rule apply to variables? Well, luckily for us, it applies exactly the same. If we have x to the 7th times x to the 12th, all we have to do, we have A as x, B as 7, C as 12, so we have x to the 7th plus 12th equals x to the 19th. That's really all there is to the product rule. But let me ask you this. What if we have a exponent expression of the form 7 to the 10th over 7 cubed? Well, the product rule that we used in the previous examples wouldn't work for this one. So this time we had to use something called the quotient rule. The quotient rule states let A, B, and C be real, then A over B over A over C equals A, B minus C. Now again, this may look complicated, but all it is, it's saying when you have a exponent in the numerator, you're going to subtract it by the exponent in the denominator. So again, let's take for example 2 to the 4th over 2 squared. Here, A is 2, or A is the first 2 that's being squared, B is 4, and C is the last 2 that's being circled. So, to find the answer, we would do 2 to the 4th minus 2 equals 2 squared. Again, if we look at some more examples, well, let's look at a bit of a different example. If we have 7 to the 1st over 7 to the 4th, when we use the formula, we do 7 to the 1 minus 4, it's equals 7 to the negative 3. Now, this is the right answer, and we're going to get a bit more into negative exponents later. And again, just like for the product rule, the quotient rule works with exponents. So if we have x to the 9th over x squared, we have A equals x, B equals 9, C equals 2. So we have, of the equation A, B minus C, we have x, 9 minus 2, x to the 7th. Now, sometimes we might have real expressions, such as an exponent raised to an exponent. What I mean by this is something like 5 cubed to the 7th. So, we have 5 cubed to the 7th. Our quotient rule doesn't work, the product rule doesn't work. Luckily, there is another one we can use. To solve this, what we were going to do is we were going to use this formula. We were going to use a, b to the c, well, a, b, and c are real. Then this is equivalent to a to the power of b times c. So that's all this formula has in, and again, it's going to work exactly like how you would expect it to work from the past examples. So if we have, as an example, 2 to the 4th cubed, we have a equals 2, b equals 4, c equals 3. So we have 2 to the 4 times 3, which equals 2 to the 12th. Okay, and again, this works exactly the same for variables. So if we have x to the 5th, we have a equals x, b equals 5, c equals 5, will give us the expression from the formula x to the 5 times 5 equals x to the 25th power. Now, what I want to do real quick is I want to go back to the quotient rule from Euler. So let's take this as an example. Let's have x to the 10th over x to the 10th. Now, go ahead and take a quick second to work this problem out. So, after solving this problem, you should have received x to the 0. You should have received this by using the formula a, b minus c, where a equals x, b equals 10, c equals 10, to row x to the 10th minus 10, x to the 0. Now, when we have an exponent raised to the 0 power, we have something very special. Any exponent, let me rephrase that. Any variable or real number raised to the 0th power equals 1. So that means x to the 0 equals 1. This also means 10 to the 0 equals 1, negative 500 to the 0th equals 1, z to the 0th equals 1. This is really a very important exponent rule that needs to be known, that when you raise anything to the 0 is 1. Now, again, let's take back to the example that was looked at in the quotient rule of 7 divided by 7 to the 4th. Again, like we solved above, this is equivalent to 7 to the negative third. But if you try to put this answer on your test or on your WebAssign homework problems, it's probably going to count it wrong. What you actually need to do here is simplify this a bit more, and we can use this using a negative exponent rule. The negative exponent rule states a to the negative b equals 1 over a to the b. Now again, all this means is that if you have a negative exponent, you want to switch the place it's in. So if it's in the numerator and you have a negative exponent, you want to place it in the denominator. If it's in the denominator with a negative exponent, you want to place it in the numerator. So from the example 7 to the 1st over 7 to the 4th, if we work out the whole problem again, we'll get a equals 7, b equals 1, c equals 4. We'll then get 7 equals 1 minus 4, 7 to the negative third, and then if we let a equals 7, b equals negative 3, we have 1 over 7 cubed. And that would be the final answer for the problem. Now, after all of that, there's one last thing we want to talk about, and that is when you have a quotient raised to a power. So again, here, we're going to let a, b, and n be real numbers. So the solution to this would be of the form a to the n, b to the n. And again, all this means is you take the exponent and you put it on a, then you take the exponent and you put it on b. So, for example, let's take 7 cubed over 7 squared. What we would want to do here is we would do 7 cubed squared over 7 squared. And this would give us 7 to the 6th over 7 to the 4th equals 7 over 2. Now, that was a very fast way of doing it, but let's walk through what I did step by step. So first, we took 7 to the 3 squared over 7 squared. And that was by the formula for when we have a quotient raised to a power. Then after that, we used the product rule discussed earlier, where we did 7 3 times 2 over 7 2 times 2. And by simple multiplication, that gives us 7 to the 6th over 7 to the 4th. Now, then we use the quotient rule, 7 over 6, 7 over 4. We do 7, 6 minus 4 equals 7 squared. Okay, for this, we will do one more example for this. We're going to do x to the 7th over x to the 4th, and we are going to do this cubed. So again, take a moment to work this problem out, and we will continue in a second. Okay, now that everyone's had a moment to complete it and pause the video if needed, what we will do is we will repeat the same step as we did previously. First, we will use the quotient rule for powers, where we will take x to the 7th cubed over x to the 4th cubed. That is just because we are moving the exponent from the outside to the inside on the numerator and the denominator. After this, we can use the product rule, and we will get x times 7 times 3 over x times 4 times 3, which will give us x to the 21st over x to the 12th. And then finally, we will reduce this by doing x to the 21st minus 12, which is equal to x to the 9th. Okay, that's going to wrap it all for today's video on exponents. In the next video, we will be walking through some more complex examples of exponents involving more variables, and we'll be tying this into simplifying the expressions that we talked about in the previous video on real numbers. But for now, that's going to end today's